Here's the part nobody's explaining clearly. AI can write code that looks perfect, clean, compiles, even passes tests, but it can still ship you into outages, security exposure, and months of maintenance debt. If you're a developer feeling anxious about the AI scare, this is your reassurance. AI is not ready to erase you. And if you're a manager thinking you can replace an engineering team with AI output, this is your warning. The deficiencies don't show up immediately. They show up later when they're more expensive or even catastrophic. AI can greatly scale output, but it can't scale responsibility. Here's the concept that explains most AI wrote it and now we're on fire stories. Engineering's not typing. Engineering is deciding under constraints, verifying with evidence, and owning the consequences. And the key distinction is that artifact is not outcome. The artifact is the code. The outcome is, does the system stay up, stay secure, stay maintainable, and solve the user's problem? A pull request can be correct and still be wrong. Correct code can still open a security hole. It can still melt performance. It can break a legacy integration nobody fully understands. If you want a gut check, ask this. If this goes wrong, who gets paged? Who runs the incident channel? Who explains it to customers? Who writes the post-mortem?
Insufficient information to compute.
I'm not anti-AI. Used correctly, AI is a serious multiplier. It's great at drafting boilerplate and scaffolding. It's great at generating options when you're exploring, summarizing docs and code so you can get oriented fast. And it's great at turning a messy thought into a first draft you can refine. In practice, AI is a very fast junior assistant. It can produce a lot of output quickly, but I don't let it make final calls, and I don't let it ship unverified assumptions. To be clear, AI will replace some tasks. Routine CRUD scaffolding, boilerplate, simple refactors, writing test stubs, drafting docs. If your job is only type what's obvious, then yes, AI compresses that work. But most professional engineering is everything around the typing, choosing the right thing to build the right way with the right risk posture, and then proving that it works in the real world. So don't compete with AI on speed. Move up one level. Decisions, verification, and ownership. If you manage teams, here's what to watch for. AI-only development doesn't remove work, it shifts it downstream. You get higher variance and delayed costs. Unverified assumptions ship to production. Security regressions slip through quietly. Debugging becomes guesswork without causal certainty. And savings reappears as incidents, support load, and churn. This is why fewer developers often turns into more operational chaos. Automation without ownership increases risk. This isn't a criticism of automation, it's a note on where the risk lives. So what stays human? Let's look at 7 different areas. We'll see where AI can help, but where it still has limits as well. This will show us where the human value still lives. And if you've been believing the AI is going to replace you hype, it might surprise you how much area this still covers. Either way, if you understand the places where you need to hold on to responsibility, then you become that person that teams depend on. Skill 1, architecting with trade-offs. AI helps by proposing architectures and patterns. It can draft decision records and pros and cons. It's useful. But AI can't reliably choose the right trade-off under your constraints. Architecture isn't about best practice, it's best trade-off for us right now. Microservices might be modern, but without operational maturity, they can multiply complexity faster than value. Caching might make things fast, but it can also create stale data failures that only show up under load. Here's what senior engineers do that AI won't do on its own. They make the trade-off explicit. They choose what failure mode they can tolerate, and they write the decision down so the team can reason about it later. Human value is picking what's right enough. defending it, and owning the consequences. Ask the questions AI can't answer for you. What's our latency budget? Acceptable downtime? Compliance risk? Who operates this at 2 a.m.? What's the cost of being wrong? Some of this may even go a step or two up the org chart from the senior developer. Still, AI is not thinking about this as it refactors a service or module. Skill 2. Building with feedback loops. AI helps by generating flows, UI alternatives, and copy. It can run usability reviews and accessibility checklists, but it lacks your feedback loop. Your users, your funnel, your support tickets, your retention issues, your business priorities. A small UX choice becomes a business decision. A default setting changes support volume. A confirmation flow changes completion rate. An error state decides whether your users trust or abandon you. And sometimes, the right UX is the one that reduces risk, even if it's less flashy. Good senior engineers know the difference between technically correct and what people will actually do. They know the confirmation prompt that nobody reads, the error message that causes increased calls to support, the feature that looks good in demos but breaks in real workflows. Minimally, they know when to reach out to the project manager or lead architect to ask those questions when they're unsure. The human value lies in using feedback loops to make product decisions. Skill 3. Validation and problem diagnosis. AI helps by writing tests and proposing instrumentation, but it can't reliably prove your system works under real conditions or explain why it failed. The hardest part of engineering isn't generating code, it's proving the code does what you think it does and knowing why when it doesn't. Tests can pass and systems can fail. An integration test that mocks an API never catches a timeout behavior. A unit test assumes valid input so it never catches parsing failures. And there's that feature that works in dev but breaks in production because of a different state. Engineering is the proof. AI can write tests. Humans decide what constitutes proof. And when things break, AI can suggest hypotheses, but humans figure out why. You should be seeing the pattern by now. AI can propose options, but choosing which option works best under your constraints, that's the part that stays human. Skill 4. Managing risk and vulnerability. AI helps by flagging common vulnerability patterns and suggesting safer code. I've seen this be very helpful, but it can't reliably own your threat model or refuse to ship something unsafe. Security is boundaries and incentives. Here's a common failure story. A feature ships fast, it works, then weeks later you discover the authorization check is in the wrong place, so a user can access data when they shouldn't, but only on an edge path. Or maybe sensitive data gets logged and the logs become a breach. Those aren't just coding mistakes, they're risk ownership mistakes. According to the 2023 State of Software Security report, over 3/4 of applications had at least one security flaw. The issue isn't detection. Tools can find them. The issue is knowing which flaws matter in your threat model. Consequences land on humans, not models. If your company replaces human reviewers with AI, they haven't just sped things up, they've removed your last line of defense. Use AI to widen review. Don't let it add risk. Keep humans as final authority. And here's the next pattern. Decide, verify, own. Skill 5. Institutional knowledge and undocumented systems. AI helps by explaining legacy code, suggesting refactors, and drafting migration plans. But it can't reliably navigate undocumented behavior and institutional constraints. Institutional reality is the part you can't Google. Real systems have the integration that must run at midnight, the vendor API that returns inconsistent types, the billing system you can't modify during that last 3 days of the financial quarter. Human value is making progress without breaking the business. Reverse engineering behavior, migrating safe slices, and avoiding heroic rewrites. Skill 6. Requirements shaping and scope control. AI helps by drafting user stories, acceptance criteria, and test outlines. But it can't reliably negotiate scope or commit to a definition of done. The hardest part isn't writing requirements. It's deciding what's in, what's out, what ships first, what gets deferred, and what risk you're taking. Most AI failures are requirements failures. The system did exactly what was asked, but what was asked didn't reflect reality. Definition of done is a leadership skill. So here's a habit that changes everything. Before you ask AI to code, write an acceptance criteria in plain language. Then ask AI to propose an implementation. Then you ask AI to propose tests, and you verify all of it. Skill 7, reliability and observability. AI helps by suggesting dashboards, alert rules, and instrumentation snippets. It can propose reliability targets, but it can't reliably manage incidents or adjust alerts to avoid false alarms over time. Reliability is discipline, knowing what to measure and what to ignore, avoiding alert fatigue, designing rollbacks so failure is survivable, and learning from incidents so the system gets stronger. The difference between 99.9 and 99.99 uptime is often 10 times the operational cost. Choosing which level you need, that's a human decision, not a code generation problem. AI can help you build monitoring dashboards, but it can't be accountable for uptime. And if you're a manager, that's the punchline. Removing humans doesn't remove responsibility, it removes people equipped to carry it. So across all 7 of these areas, AI can generate artifacts, it can be a help, but the real jobs are decide, verify, and own. It's all human stuff. Companies don't pay for code, they pay for outcomes. Safe releases, stable systems, secure data, satisfied users, predictable operations. AI changes the work, it accelerates part of the work, but ownership stays human. So what's the winning workflow? AI drafts, humans decide. AI suggests, humans verify. AI accelerates, humans own the outcome. So here's how to upgrade yourself. First, stop prompting for code first. Prompt for constraints first. Ask AI, what constraints do you need to know before implementation? What could go wrong in production? How would we detect it? Second, build verification habits. Tests that reflect reality, instrumentation that proves behavior, and code review standards that catch risk. Let AI generate drafts, but make humans approve based on experience. Third, practice one level above coding. Document your design decisions. Understand threat modeling. Define acceptance criteria before building. This is how you become the person teams trust. Fourth, follow your code to production. Monitor it. Fix it. Write a mini postmortem. Repeat. Because the market doesn't reward code generation, it rewards outcome ownership. If you're a developer, AI is not your replacement. It's your multiplier. If you build the skills that turn AI output into production outcomes. If you get reorganized out because management thinks AI is going to replace you, you're better off not being at that company because they don't understand what AI is capable of. If you're a manager, the winning play isn't replace developers, it's upgrade developers and keep humans accountable for decisions, verification, and risk. If you want, I can do a follow-up with a practical code review checklist for using AI without raising your incident rate. Like and subscribe if this helped, and don't forget to check out what's next.